Access.
So good afternoon. This panel is talking about virtual private networks, trying to provide some reality and perspective on the state of the world relative to some of the technologies involved with virtual private networking. So basically the things we're going to try to do is talk about what is a virtual private network. It's certainly kind of a vague idea, lots of different concepts. So we'll talk about that and some of the technologies, the technical building blocks involved in making a VPN. Talk about some of the different services that a service provider could offer, VPN services, and then also talk about the challenges around that and some of the proposals and technologies that have been developed to address those challenges, specifically in the area of interoperability and scalability, manageability, and such. So, I guess this should be yours, right? So, again, to introduce people, Paul, myself, and then Kirti will be speaking. And at the end, we'll have a session for question and answer. I would certainly encourage you to, as we're going through the presentations, try to think about some questions you may have, and we'll have a period of time at the end for that. So first I'll introduce Paul Ferguson.
Well, this is actually not a very original presentation. I basically just extracted a couple of choice slides from a white paper that Jeff Houston and I did a couple of years ago on what a VPN is. And it's still something that I still passionately about insofar as definitions. This is certainly not an official corporate Cisco vision, because there's a lot of people in Cisco probably like to hang me for some of my opinions, but nonetheless, virtual private network, of course. I like to define it as, anytime you try to define communities of interest, what are communities of interest? Whatever your definition of that, kind of a ships in the night type of thing, where each, community has no conceptual knowledge of any other existing community. I'll say a little bit more about that in a moment. And of course, like any other of our favorite three-letter acronyms, VPN is one of the ones that has a lot of hype, a lot of marketing momentum, a lot of religious issues. Go ask a math geek, what a VPN is. The first thing he'll say is IPsec. You go ask, MPLS person what a VPN is. They'll tell you it includes MPLS. There's hundreds of different, literally hundreds of different definitions of what a VPN is. There's lots of market point vendors who make black box VPN stuff. I'm not saying that's good or bad. I'm just saying there's lots of stuff there. Okay, what I like to do is I kind of look at it from this perspective. And again, I just reused some pictures that Jeff Houston had made up. I just had to paste them in here as a single object, so I couldn't really add it or modify it. But think of it this way. Think of the application, the protocol stack. And think of, there's a subset of that, the TCP/IP model. We've got application transport network and link layer. And I'm even going to include like the physical, the file layer in here. You can basically have VPNs in any layer there. So think of it this way, link layer encryption. When I used to work at Sprint, I used to have customers that were really anal retentive about security, and there was no real good way for them to do it across, like, say, frame relay networks. But they used to use encryptors, DSUs, that encrypted the stuff before they ever put packets on the wire. So that conceptually satisfies my definition of a VPN. Or it could be, private frame relay networks or ATM networks, public frame relay networks. We've got separate, discrete layer 3 networks riding on a common layer 2 infrastructure. We used to build lots of private networks for people, and basically it fits the ships in the night definition. Now, sure, there's probably some security issues there, but as with any security issue, you have to do a risk assessment to determine how important it is to you. You probably can't see this very well. This is kind of illustrating what I'm talking about. You've got a common layer 2 infrastructure like a public ATM network. You've got, like, discrete layer 3 networks that have no conceptual knowledge of one another, and the ships in the night. For all intents and purposes, they're each their own community of interest. But, technically it's a VPN. Okay, let's look at layer 2.5, MPLS. It's not really layer 2, not really layer 3. There's a lot of momentum right now on standards track type issues of building MPLS VPNs. Okay. IPsec. Transport layer security, RFC 2246, SSH. Conceptually, those are kind of VPNs. They're virtual, they're private. Is it a network? Well, not really, but application encrypted email, PGP messages, or any other PGP-enabled application. Any application which has encryption between communities of interest. Those are VPNs, really. And so if you go back down to the PHY level, you could build VPNs out of pulses of light. Everybody has their own wavelength. I mean, if you think about it anyway, no matter what you do, what layer of the application stack, all that traffic is going over the same pulses of light anyway. So, very quickly, that was basically what I said. VPNs take on various forms. Is there any right way? It depends on what problem you're trying to solve. You need risk assessment tools to determine the right level of security. There's a reference for the paper that we did if anybody's casually interested, and a URL.
Okay, thanks, Paul. Now I'm going to talk a little bit more in detail, digging down into some of those things. Paul was kind of providing the overview. I'll talk about some of these different technologies in a little bit more detail. Again, trying to define a VPN. I think this is a challenge that pretty much any of us have faced when either your customers have asked you to provide a VPN solution, or maybe your boss came to you and said, we need to offer VPNs, trying to figure out what exactly it was. So just a couple of definitions, but just to reinforce what Paul was saying, I think really the only real true private network is when someone goes and they build their own, take all the physical plant, whether that's copper wire, fiber, switching, transport, everything. So that's a true private network. Anything above that in the protocol stack is shared. So that could be a TDM network or frame relay, ATM network, etc. We're sharing different pieces of the same facilities. But since this panel is kind of focusing on IP-based VPNs, and NANOG is obviously more of an internet-centric body, talk a little bit more about this in detail. So, again, what are we trying to accomplish? Basically, in this case, we have these IP networks that we build, typically for best effort internet connectivity, and maybe there are ways and things that we can do, run over that to enhance the utilization of those that infrastructure we built. So that could be collapsing multiple networks onto other networks and other services onto the existing IP network, for example. In particular, a couple of things would be sharing a local loop. If you are a provider and you have your facility, you've brought in lots of T1 lines or DS3 lines, things like that, it's quite painful trying to manage all the different wires and such. Just like the subscribers, if they have one T1 line for their internal frame relay network, another couple T1s for their voice network, another T1 line for their internet connection, they can collapse all that together and buy it from one service provider. May make their life a little bit easier. And then, and this is something that Curdy will dig into a little more deeply, is the idea of even beyond sharing some of that infrastructure is the chance for the service provider to provide an outsourcing opportunity and bring some of the network functionality into the service provider network. So I'm just going to go through a couple of the different models of virtual private networks. Remote user access, CPE-based VPN, and then a couple of more core-based VPNs, one more MPLS-based, and then a provider-based layer 3 VPN. I'm going to speed through these quickly. Each one can take half an hour or an hour or a couple of days to explain, and we only have 20 minutes to go through this particular part of the presentation, so I'll go pretty quickly. But I provide some references throughout. So when I'm talking about remote user access, what I mean in this case are the idea of some kind of typically a switched user, that is somebody who's not constantly connected to the network, getting access back into via a shared infrastructure back to some corporate headquarters, for example. And so in the mid-1990s, I guess in 1995-96 timeframe, saw a bunch of protocols emerge, HEMP, PPTP, L2F is the other one I meant to put up there. It's a slide bug. But these are basically functionally similar protocols that provided this idea of a dial-up user connecting into a network, authenticating to the network, and then sending their tunneling their traffic through the network back to some home gateway. And these multiple protocols have kind of consolidated now. The IETF has done a protocol called L2TP, and that's actually been issued as an RFC 2661, and there are various drafts that talk about extending that protocol. And we're at a point of maturity where that's actually starting to be deployed. When I talk about a CPE-based virtual private network, what I mean there is a scenario where either the service provider or the end user runs some kind of technology that runs, again, on the CPE devices of the network. So that could be IPsec tunnels running through the network, or GRE tunnels, or IP and IP, etc. Basically, the tunnels run from a CPE device to the other CPE devices, and providing this logical overlay network over the common core network. An interesting aspect of this one is the service provider doesn't really have to be involved at all. If the end user buys those routers and configures GRE over the internet, there's still just IP packets in the middle. And the user can run basically whatever they want over that GRE tunnel, for example, or that IPsec tunnel. However, there's also an opportunity for the service provider to, as either bundling those routers or managing those routers, to basically, again, provide an outsourcing function for that corporate user. And other ways that the service provider could add value are doing things like marking the traffic as priority, if it's VPN traffic versus best effort internet traffic as it's delivered through the network. And this is also something that we've seen that many providers are actually starting to do. So some of the trade-offs in this model are that it's actually, from a simplicity perspective, it's actually pretty much about the same as general internet access from a service provider perspective. That is, if the client continues to manage the CPE devices. But if I guess it's the managing of the CPE is the complex part, where you have those end-to-end tunnels, and you have to manage a large number of IPsec tunnels or GRE tunnels, whatever it may be. Next one I'll talk about is the idea of a layer 2 VPN, and a couple different implementations. Again, as Paul alluded to, basically the easiest way to think about this is just a frame relay or ATM network. You have a frame relay, a bunch of routers around the edge. Now, either the user could manage those routers, or they could be bundled with the frame relay service and be a managed router service, in which case the service provider actually provides that as a VPN service, interconnecting all the sites of the network. And in the case of frame relay and ATM, this is actually a fairly mature, frame relay has been around for several years, seems to work fairly well. And from a service level agreement perspective and such, it's kind of a well understood model. And using the virtual circuits between the sites also makes it easier to do capacity planning. We understand how much traffic is going from New York to Chicago and how much traffic is going from Chicago to San Francisco. It's a lot easier to do that rather than over a broad internet network. So Some of the trade-offs on this one, from a configuration perspective, again, if you have to configure millions of virtual circuits for a very large network, that could be fairly complex, but there are tools that help to ease that configuration burden. The issue can be, as the network grows, though, and you have a large number of virtual circuits, that each of those end routers needs to maintain a lot of adjacencies, and the scaling can become quite an issue there. One of the nice things about this is maintaining this model. There's quite a bit of infrastructure investment in frame relay technology, both in the core networks and in the CPE devices. So, again, as Paul alluded to, MPLS is kind of finding a role here in VPNs also. So, this is one of the places where this model is one place where MPLS can fit in, basically taking what I call a traditional layer 2 VPN, that's a frame relay or ATM-based core, and just like several years ago we heard that how ATM would be the core and all services would run over it, it's kind of flipping that around where you use ATM or frame relay at the edge and use MPLS at the core to carry that frame relay or ATM traffic and maintain, instead of having a ATM virtual circuit, now we have an MPLS label switch path going through the core. And this allows the opportunity to run these multiple services over the core, the shared infrastructure, the shared MPLS infrastructure. There's an internet draft that I refer to here that describes this, and Juniper has an implementation. Doesn't comply with that draft, it's similar kind of technology. And this diagram kind of shows the idea. So you have these subscribers, and out at the edge of the network, they'd run frame relay or ATM encapsulation. All the traffic that comes in on a frame relay DLCI gets handed off to an MPLS LSP to make it through the core of the network, and then at the far end, the MPLS headers are taken off, put on a frame relay encapsulation again, send it on to the user. So again, from the end user perspective, it maintains that frame relay model or the ATM model. And that's why I call this a layer 2 VPN, because to the user, there's really, the service provider doesn't touch IP at all. So you could run IPX or AppleTalk or SNA, whatever, over this, or voice even. Kind of frightening, huh? So what are the trade-offs here? The challenge here is it creates some additional configuration burden. So from the provider perspective, they need to do that mapping of the frame relay DLCIs onto the MPLS LSPs and then back onto the frame relay DLCIs, for example. So some of that can be automated, but there's still additional configuration that needs to happen. And from a subscriber perspective, again, it looks, that's the end user and the CPE devices, it looks just like a frame relay network. So you have the same kind of scalability issues you have in running a frame relay or ATM network from the CPE perspective. And just in terms of scalability, the same issues. You know, if you have the core network has a lot of label switch paths now instead of frame relay virtual circuits, but conceptually they look very similar. And then the same on the subscriber side, a bunch of virtual circuits on the edge. The next model that I'll talk about just quite briefly here is what I call a provider-based layer 3 virtual private network. There are a couple of RFCs that talk about this, 2547, and one that's been a draft for a while was just issued as an RFC, 2764. That second one actually talks about a variety of different things, but there's quite a bit of coverage of this idea also.
Which are those? Which ones are those?
Well, the 2547 is one that was written by Cisco folks primarily, and 2764 was written by a variety of people, including Nortel and Juha Heinonen from Telia Finland, whatever they're called these days, and somebody else. It's kind of a collaborative effort on that one. So it's kind of there's a bunch of RFCs issued in the areas of VPNs, and these are the two that have kind of made it through the process as being issued as informational RFCs now. So anyway, the idea here is that the subscriber kind of treats that access link as a combined access link for multiple services again, except in this case, rather than in that provider edge box, just doing a mapping from a frame relay DLCI, for example, onto an MPLS LSP, the service provider box actually touches the packets at an IP level and does routing. So in general, the nice things about this are that at least in a typical, relatively straightforward network, there's minimal additional configuration. You can make it look just like a small enterprise network with default routing and such. The provider's edge router is where some of the complexity starts to appear because you have multiple forwarding tables, one for each of the VPNs that are connected into that box. And then in most of the proposals that are available in this area, we use typically BGP to carry information across the core of the network to maintain an idea of, in each of those provider edge boxes, as to what VPNs are connected where. So this model supports, even though there are these, the provider network does routing for multiple different customer networks, it does support the idea of private address space on the client networks because of the use of multiple forwarding tables. And typically, from a core perspective, we'd have a full mesh of IBGP sessions anyway between those aggregation routers, and that IBGP mesh can be used to carry this VPN information throughout the network. So, again, from a provider perspective, as long as the VPNs are relatively simple, then it's pretty straightforward static configuration to do. But the complexity doesn't just go away. If you have a more complex enterprise network and you're providing a VPN service for that complexity has to be handled somewhere in the network. And typically, the idea here is that the service provider is absorbing some of that complexity. So, and the same is true with regard to the subscriber. If you have a simple network, it's fairly straightforward to do that configuration. From a scalability perspective, certainly, again, if there are simple networks, then it's very manageable. However, because of the multiple forwarding tables, there is certainly an opportunity if you're providing an outsourcing or a VPNs for a bunch of large enterprise networks that have many, many prefixes in each, you're carrying those in the forwarding tables, then the absolute aggregate size of that forwarding table in that provider edge box that has a forwarding table for each of the VPNs can be quite large. And in addition, there's typically some kind of routing adjacency between that provider edge box and the customer network. So there's some interplay between those two boxes. So basically, the provider edge box may be running multiple instances of routing tables or of routing protocols. So from a scalability perspective of the subscriber to the network, however, this is quite nice, where they used to have many local loops. Now they can be collapsed into one, and they can push some of that complexity away from the CPE device that they used to have to manage onto the service provider. So I've talked about a bunch of these different models, and just to kind of summarize all that, any of these models that have what I call customer-centric tunneling, that is from more end-to-end, they're easier for the provider. That is, the configuration burden remains closer to outside the service provider network typically. However, the service provider does have the opportunity to do things like provide service level agreements and do some special class of service treatment and things like that on the traffic that's VPN traffic. So for the service provider implementing VPNs, sometimes, though, this issue of scalability and providing value-added features can be at odds to each other. That is, the more services that you collapse into the network, the more difficult it is to scale that up. This just kind of talks about some of those different issues, the number of sites in the VPN, the complexity of the networks if you're outsourcing a Fortune 500 network that has 1,000 sites and all the prefixes and multi-home to the internet, all those things, obviously you try to absorb some of that into your network, it can be quite complicated. So, what is the answer? The answer is, as it frequently is in this business, it depends. So, depending on the subscriber and their needs, it may be more appropriate to use some kind of layer 3 functionality absorbed into the network. In the case where you have a complex network, you're just trying to provide a relatively dumb transport, maybe providing some kind of layer 2, MPLS layer 2 path through the network makes more sense. So it really depends on the subscriber. Some of them want to keep that functionality to keep control, and they just want cheaper dumb pipes through the core of the network. Some of the subscribers, though, they just as soon push off all the complexity onto the provider. That provides an opportunity for the provider to do some value add. That's where maybe a layer 3 VPN service makes more sense. So what I expect to see as this IP VPNs become more popular and some of the technology continues to mature is that we'll see some hybrid and a range of different solutions. So again, we don't see there's any really one-size-fits-all these trade-offs due to a variety of factors. And that's all I have. I'll turn it over to the next speaker. Give Paul his PC back.
Okay, so let me first quickly introduce myself. I'm Kirti Melkote, and I'll be speaking with a colleague of mine, Gil Tene, who's sitting in the corner. I'll cover sort of the first few slides and do the introduction, and Gil will talk a little bit more details about the technology itself. I want to quickly address the whole VPN market itself from a buying behavior standpoint. If you look at who's basically interested in a VPN type service, it's basically everybody out there. The large enterprises, the Fortune 500, Fortune 5000s, and the small medium enterprises. But what they look for when they're purchasing a VPN solution are different things. A large organization like a Fortune 500 or Fortune 5000 type business typically buys infrastructure from the service provider, buys pipes, and then they have their own routers, and they have essentially their own network that they operate and run. A small enterprise, on the other hand, actually today are forced to actually run a network. They have to buy infrastructure and run, but ideally they don't want to be in the business of running their own networks. They want a completely turnkey solution and an outsourced service that will take care of all their needs. Because firstly, they don't have the money, first of all, to go buy all the, essentially all the router and all the different pieces of equipment that it takes to build a network together. And most importantly, it's very difficult to find highly skilled people to go build your own network services. So this is where I think there's a lot of opportunity for providers to come in and add value and expand the VPN offerings to the overall market. So that's the only non-technical side, I promise. So this takes us to understanding what a VPN is and what the definition is. Paul just mentioned the definition as the emulation of a private network over shared infrastructure. But it's important to understand what you're trying to emulate. Again, going back to the small medium businesses versus large enterprises model. If you're trying to emulate a small medium enterprise network, the requirements for outsourcing are basically access management of multiple different types of subscribers, be it dial, which is predominantly the case today, migrating more towards telecommuters that might be coming in on broadband technologies like DSL or cable. They have a few fixed sites. It's typically a business that might span a headquarters and a couple of sites, and they don't have the need for a backbone per se, but they still do have a requirement for multi-site connectivity. And then lastly, they want to connect to the internet. So which means they have to buy a firewall and manage their own firewalls. That's basically it if you're looking at what your requirements for outsourcing a small medium enterprise network is. But if you look at a larger enterprise, the requirements are a lot more diverse. As we all know, I mean, larger networks typically have their own backbone. They have a hierarchical network infrastructure where they have a core, distribution, access, and so forth. And outsourcing a large enterprise network is non-trivial. You have to think of it in terms of the way they think of their network, which is how do you outsource the core, how do you outsource the access, and so on. And of course, the requirements vary as well. If you're looking at outsourcing the core, you're basically looking at very fast transport and traffic engineering. If you're looking at outsourcing the access, it's different. You're looking at how do I tie in my branch offices, how do I tie in my remote offices, whether it's frame relay or DSL, whatever technologies there are out there, how do I get my telecommuters into the network, and so forth. So let's begin first by looking at how do you approach this problem of a large enterprise network and how potentially you could provide an outsourced network solution for this large enterprise. The first element of a large enterprise network that we can look at outsourcing is the core itself. And it happens today, right? They basically end up building their own routed network by buying leased lines from the provider. That has evolved to a model where it's frame relay DLCIs. And now, of course, ATM virtual circuits. As the speeds are increasing for the core itself, it's moving towards ATM and MPLS as becoming the preferred technologies to be able to build this core infrastructure, and maybe over time even lambdas. So fundamentally, this sort of outsourcing of the core itself looks like this, where the provider infrastructure is all layer 2, and you're providing either frame relay DLCIs or lease lines or ATM PVCs or MPLS LSPs. And the customer themselves owns the routers, terminates these circuits, and manages the routing between the sites. A layer up in terms of a service that you can provide, an outsourced network service, is when you suck the customer's router into the network. This is called virtual routing, where you could provide a virtual router sitting in a box in your network. And basically what you end up helping the customer do is to get rid of the thousands of virtual circuits that they have to manage, and manage instead a core, or rather a virtualized element inside your network. Now, of course, the management of this virtual router could either be done by the customers themselves, which might be the case when, let's say, they've built a large OSPF backbone and they want virtual networks sitting in the service provider cloud, but they still want those virtual routers to peer with their routers and be part of their backbone, if you will. So this is sort of the provider owns the infrastructure, but the management of the routing is still being actually done by the customer. This is one model. The other model, of course, is the 2547 model, where it is a layer 3 VPN. The provider edge is a router as opposed to multiple virtual circuits coming in. And the provider edge may actually even potentially peers with the customer routers using OSPF or RIP or whatever technologies. But in the backbone side, they use BGP4 to piggyback the VPN information across the backbone. So this layer 3 backbone that essentially that you end up providing the customer is opaque to the routing protocols that are running inside the customer's network. So that's the basic difference between the outsourced virtual router concept versus an outsourced layer 3 VPN concept that's shown here. So we just talked about virtualizing the core and all the different options of virtualizing the core. Moving on to the virtualizing the branch itself, it's different. What you worry about in virtualizing the branch is more about bringing in the telecommuters via dial, connecting multiple remote sites using frame relay, which is the case today, but potentially evolving to connecting fixed sites using things like DSL or cable or even fixed wireless. So here you're looking at managing access, managing subscribers. And by nature, when you're managing access, if it's dial, it's PPP. So you have to have dynamic configuration and joining into a VPN when a subscriber dials into your network. You have to, if it's DSL that you're using for telecommuters, then you have to have, if you're using a fixed site bridge deployment model, you have to have some sort of a DHCP server sitting in the network that doles out the right IP address depending on which customer comes in. So it's more of an IP address management and dynamic configuration issue that you're trying to address at the virtual access. And of course, to provide the full total outsource solution, you're actually providing a virtualized core and multiple virtual access points tying into this virtual core, which could potentially end up being all managed by the provider. But more likely, there are some parts of this that will be managed by the customer and some parts of it which will actually be managed by you. So you have to work out the interworking relationships and what the agreements are going to look like. So that's sort of virtualization of a large network. But when you move the problem to virtualizing for a small medium enterprise, the problem definition changes, as I mentioned earlier. It's a much simpler set of things that you're trying to outsource. You're trying to outsource basically what the customer wants, a small medium enterprise customer wants, is just take the network away from me, manage it for me. I have a headquarters where I have some servers. I have a few branch offices that want to connect to the shared resource. And then I have a few telecommuters scattered maybe all around the world that want to connect to me. And the way it looks is, you have, the way it looks today, you have to, a small medium enterprise has to go buy their own router. They have to buy the pipes from you guys, from the providers, and manage this connectivity into a router. They have to buy the internet access themselves, buy a firewall, and manage the security policies going to the internet. And in some cases, they also provide some VPN capabilities using CPE-based VPN technologies, using IPsec. So you have an IPsec client implemented on a laptop, and you're dialing into the corporate network through the internet. That's sort of a rudimentary form of VPN technology that's being deployed today. But we are looking at basically taking this model from a mass market standpoint and looking at how to outsource this whole piece to the provider. At this point, I want to turn this over to Gil, and Gil will explain a little more in more detail about how we actually end up doing this.
Hi. So I guess Kirti did a really good description here. And this is a pretty good picture of what a small, medium-sized business would do today. And there's nothing wrong with that picture, except that there's so many of these small, medium-sized businesses around that nobody can run these networks. The outsourcing of these networks is a way of providing people with service that's simple, that achieves everything that this picture does, but without them needing to either have an actual guru that can do firewalls, routing, and everything else, or consultants to do the same. So let's look in stages at what piece of this network, of this picture, can be taken over by an outsourced access network, and go from there. So to start with, convert that picture and keep your internet access separate for that main headquarters site, but outsource your access network as a full service network. Start off by a provider providing a link to that headquarters that then ties into a private network or a virtual private network just for this customer that has remote offices, or instead of these remote offices, you can think of any fixed line application like DSL or perhaps cable in a way, hooking into these headquarters. The fact that they're hooked in this way over a private network, not over the public internet, provides them with a secure network that gives them access to their applications. And the internet is separated still through a firewall, and IPsec clients roaming around the world still access it through the same line. Now, to that you can add DEL telecommuting access, where instead of dialing into a public internet access or into a RAS located inside the corporate building, it would be down into a public, into a LAC, basically, that would tunnel into this VPN. As long as the DEL call is terminated on net within the provider network and reaches one of the VPNs over a non-public link, then DEL telecommuters can also join a VPN without a security issue and without traversing a public network. Internet-based, or basically roaming road warrior types that go anywhere in the internet and don't have access to these DEL numbers would still be required to use some kind of an IPsec solution to access the corporate site. And then your next step is to try and take those over as well and provide some kind of an on-net termination for off-net IPsec clients, so that these IPsec clients get on the internet somewhere and terminate their IPsec connections in the provider network and gain access to the VPN that way. Now, in all of these, the internet link and the security have been separated from the network, because all of these networks basically outsource the access side of the network for the corporation. the corporation has an internet link, if they manage their own security over it, that's what's assumed here, and they're trying to get rid of all their management issues around internal links, whether it's telecommuting internal links or remote branch office internal links. And security is kind of assumed where all internal links are secure, don't traverse exposed public networks, and the internet is secure through a firewall at its edge. Then the next step from there, where a customer wants to really get rid of all their entire network problem or network management problem, is to go and say, I just want one link to the world, and I want that link to be, this is the internet, this is my VPN, this is everything, it's my default route. And in such a situation, the firewall is then taken over as a function of the network and managed separately for each of these customers. And the key thing in a situation like that is a firewall needs to be at any edge of the network that's connected to the public internet. If there isn't a firewall there and there's clear traffic between them, then the whole network is exposed. A key benefit or thing that drops off the list of scalability issues when you go to a network that totally outsourced all services is that in this picture there's no longer a need for a private address space or a fixed address space for the VPN. A VPN that is an access VPN but connected to the public internet has to have a known address space because the internet needs to talk to all these people and they need to talk to the internet again. And that generally means that dynamic membership of addresses within this space is not possible unless there's very sophisticated routing at the edge of the subscriber and the internet. In a picture where, again, the full service is outsourced, then it is possible for the provider network to dynamically manage membership of addresses within different VPNs and thereby avoid managing thousands or tens of thousands of different address spaces for different VPNs. They could still provide private address spaces, but public telecommuters, IPsec clients, DAO telecommuters could all use public shared pool addresses and dynamically join a new VPN. So there are various forms of dynamic address membership in VPNs out there to handle that. Now, on a scalability point of view, a critical thing for managed services or outsourced services for VPNs is the provisioning process and the ease of provisioning. Now, on the left-hand side here, we have what a manual setup of a VPN of any of the types we showed before would take. Going node by node, you would have to actually set up individual tunnels, IPsec tunnels or MPLS tags or whatever it is across your backbone. You would have to set up routing instances on a per VPN basis and adjacencies for each of the tunnels. And you would have to do that for each VPN on every node in the network. That becomes a very, very big task. In a small network of 20 nodes and 1,000 VPNs, you're looking at 20,000 instances of things to set up. Now that is probably not a manual setup process that a provider can really take over. And in order to address that, a provisioning system that controls VPN service creation and actually it sits a layer on top of the left-hand picture is necessary. It has to have a concept of where the VPN is, what its functionality is, and how to configure it in every member node or member edge node of the VPN. And without that, it isn't practical to actually create a scalable outsourced service because all you're doing is taking over the menial work that every customer would have had to do on their own without simplifying the network. One last necessary part here is a way of providing customer network management or visibility for the customer into their managed network. The whole network could be taken over, or parts of it could be taken over, but the customer needs to be able to see what their accounting logs look like, what their service looks like, whether SLAs are being met, and other things. Whether that is a monitoring function or an actual hands-on configuration function is up to the level of service and customizing that you as a provider provide. So to summarize, there are tons of options that were presented here. And, I think that when we started, whenever I walk into a room talking about VPNs, I kind of hold my head for a second, because walking in here and talking about VPNs is like walking into Safeway and talking about food. Everybody has a completely different concept of what it is. Every customer wants a different thing, and there seems to be more and more agreement about what a VPN means, but it's still pretty fuzzy. So it is important to see what services the customer really wants to have outsourced and what the VPN that they need is. It could be anything from an outsourced copper wire to a totally outsourced services network. Ease of provisioning is critical for mass market scaling. Without creating the provisioning, automated or assisted provisioning on the provider side, there is no possibility of scaling to the actual number of customers that are out there that want these VPNs. And then customer visibility into networks is also necessary. It is not an opaque service. It needs to be something that, in order for customers to actually buy into this versus their existing networks, they have to have visibility at least to the SLAs, the connectivity, and some kind of accounting logs, perhaps security logs into the network when that is outsourced. So I'm pretty much done and covered then. That's it. Okay. Sorry for that last slide. Didn't mean to skip it.
This that kind of wraps up the formal presentations. Now we can take questions and answer. I guess if the lights can come up so we can actually see something up here, that'd be good. Thanks. So there were some mics around, and if people have any questions about any of this, we talked about a pretty broad variety of things at a fairly high level, and I think the speakers here are ready to address more details about those different technologies and kind of what's real and how does it really work and things like that. So,
Please ask. Hello? Mike, turned off.
General question. One of the technologies that was virtual routers and remote management of virtual routers, and I kind of wondered how much customer requirement people have for that, and how much management of your network would you be willing to give away to the customers?
so I think that was a question where everyone appears as a vendor, so I think that was more of a question to the providers in the audience in terms of...
We don't always want these manually.
The question was...
There you go.
Thanks. I think the mics are on now. So I think the question was, how much are the end users willing to kind of turn over and outsource that kind of function, things like turning over the routing of the network into the provider's network into some kind of virtual router model. So do any of the providers out there have any insights on that?
I was hoping somebody would have some interesting questions because Dave has a list of them that he's going to pose if you guys don't do it, and that's unfortunate.
Maybe everyone just wants to go back and have another break. Go get like NANOG cookies or something. So maybe this is a good question. Is it the case that VPNs are something that just the vendor community is pushing on the service providers and none of you guys really care about this stuff? Certainly it was very difficult for me to, I actually tried to solicit service providers to participate in the panel and was not able to find any to participate, which is kind of disappointing to me. I'm a core router guy, so I don't, we're kind of in the middle, and we don't have a whole lot to do with what happens on the VPNs on the edge. But anyway.
Tom Barron from Envoy, formerly known as MRNet. We've actually have our salespeople responded to an RFP for a private medical network, and being able to reuse the same skill sets and equipment and so on as our internet service, but actually use separate routing tables is very valuable. That's not the same as having the customer manage that virtual router, but something in the real world where we're doing a virtual private IP network. So there.
Well, is it the case that, the feeling I get from the past couple of years of how the term VPNs have kind of evolved is, it appears to me like people have been developing the technologies, and each one of these technologies are kind of like tools in a toolbox, and people try to evaluate what problem they're trying to solve, and they pick the right tool. And if that's the case, then I think that's a good thing.
We saw customer demand for VPN stuff really picking up about halfway through last year, and one of them actually implementing VPNs for quite a few customers, mostly sort of multi-site core routing things, because we do that with VPCs, but remote access kind of VPNs where people are routing in, they want to turn the tunnel and so forth. I think what we were seeing was driven by two things. First of all, people doing Y2K assessments, finding out that actually they didn't have Y2K problems, they had security problems. And
That's a good thing, too.
At least something came out of it. Users going home and having DSL connections, and the employers being nervous about customers using full-time connections to get in, whereas they weren't so nervous about customers routing directly into a corporate terminal server, for instance. So, yeah, we've done a bunch of these since August, September of last year, but they've mostly been L2TP or
I think that's certainly one of the factors here is that we have all these different technologies between the L2TP, et cetera, and IPsec and MPLS. There are a lot of different tools in the toolbox, but a lot of them are still evolving. So maybe specifically on the area of security, the IPsec suite of standards has been evolving in the IETF. It seems like decades, but maybe that's only internet years. It's been years anyway. So maybe it's a question for the panelists, and then if anyone in the audience wants to address that, is what we think the state of the world is relative to IPsec. Is it ready for prime time? Do people really use it? And is it addressing the needs? So if either.
Well, I think the jury's still out. I think there's another one of those situations, I think, where, the market will decide. I mean, all of us, service providers, vendors alike, are pretty customer-driven, in what they deploy. And customers are the ones that have to make the decision. I mean, they're not going to let, 9 times out of 10, they're not going to let people just shove things down their throat if it doesn't solve any particular problem. I mean, the worst thing you can have is a solution looking for a problem instead of a problem looking for a solution. So I just don't think, from a personal perspective, the market has actually decided yet what it wants. I mean, if that were the case, people would have wrapped their brains around this a long time ago, and certain marketing departments and service providers figured out some way to bring in new revenue in the door, and would they be deploying VPNs all over the place? We wouldn't be sitting up here having this panel discussion, I don't think. So.
I think what I'd add to that is I totally agree with your statement about the provider space. In the provider space, IPsec is not taken off yet, and the jury's still out. However, as a technology used by enterprises for implementing VPNs, the VPNs they run themselves, not the VPNs they buy from you, I do believe that the jury's come back. Interoperable IPsec is one thing. Completely standards adhering IPsec is one thing. But enterprises are deploying VPNs. Virtually every internet-based remote access into corporations now is IPsec-based. They tend to be proprietary, IPsec-based. And the interoperable clients for them are still not out there. My honest hope is that this year, with Microsoft actually shipping something that is based on IPsec in an OS that doesn't require a third party anything, that will become a true standard. But as far as service providers actually offering IPsec-based services, that is yet to happen.
Even Lester, and everyone. My question is just the management of this. For this to be really useful, when you talk about you have to automate management, as you mentioned, do those tools exist yet? Vendors providing use HP OpenView to do it? Or what people actually doing with that?
Very, very good question. That was actually my next question, was exactly in that area. And you guys alluded to this in your presentation about service provisioning and the idea of customer network management. So maybe talk about service provisioning first, kind of what exists there and how does it work, and is it standard, is it scalable, all of those kinds of things.
So I think to start off, we're not here to do any product pitches. So what I can say is there are single vendor solutions that provide provisioning of VPNs today from more than one vendor. However, since the standards for what VPNs exactly mean across an interoperable IPsec, MPLS, or anything else aren't fully there in a service provider environment, you won't really find a provisioning system for something that isn't well defined. So it does tend to be today that a provisioning system is a vendor-based provisioning system for a specific solution that could be network-wide. Our hope is that within the coming years, with more and more standardization, there would be tools that will be able to work with some common base level that's expected. Same as it's expected that static routes work and IP works. It should be expected that IPsec and IKE is interoperable and you can build a VPN based on it.
What he said. I'd also add to that, I mean, the provisioning, the configuration and management, and the tools to do billing if, you know, it's something that you're deploying as a value add, you know. This isn't really an science experiment anymore. I know people out there running businesses doing this stuff. I think, again, it's one of those issues where people will have specific vendor implementations of some of these things, but it also might be the case where people are kind of wait for some of the standards to all kind of shake out so they don't have to go back and build everything from the ground up. I don't know that for sure. I'm just making a kind of leap of faith there.
Well, along that line, I guess we talked about a bunch of different things. Again, MPLS, IPsec, et cetera. The implementing some kind of differentiated services in conjunction with virtual private networks. There's a whole bunch of these different building blocks, and if you watch the IETF announcement mailing list, you've seen over the last, I don't know, year or two, there have been probably a dozen or 20 different proposals that have come out describing different techniques for doing VPNs. And I know a couple of IETFs ago there was a BOF on VPNs, but kind of got, I don't want to say shut down, at least it hasn't happened anyway. There's really no working group. And just interested in a perspective on how important the panelists think, and certainly feedback from the audience on how important is there to be a standardization effort for VPNs, whether that's a framework, or is it good enough to just standardize these individual technologies and then plug them together and let the vendors provide things that kind of help glue all those pieces together?
Personally, I think it would be difficult, if not impossible, for the IETF to standardize VPNs. Simply because of the fact the second question exists and there are already standards in place for some of the technologies. And again, from an engineering perspective, I'm one of the people that firmly believe that, you know, the more knobs that you have and the more that you turn on, the higher statistical degree of failure that it poses to your networks. So I overheard a conversation in the lobby yesterday where someone was talking about, having 7 queues on a router and running MPLS and having, 8 or 9 different classes of service and all this other stuff. And I just kind of shuddered because I think this is, is going to implode on itself because there's just too much stuff in there. But if you've got 2 routers, you can probably pull it off. But if you're dealing with an international backbone or very, very large network, you have to also realize too, the networks are so complicated that your support staff can't figure things out when things break. It's completely self-defeating. But on the original question, I don't think the standardization of VPNs in and of itself is possible.
I guess slightly different perspective is it's not standardization of VPNs per se, but the technologies that, underlying technologies like IPsec and MPLS and how you use them to do VPNs is basically where there needs to be some better specifications, I feel. Right now we have 2 informational RFCs, the 2547 and 2764, which are suggestions pretty much on how to do things, right? But they're not standards. There's no real hardcore specification that says this is how you can go do things. And that's where I think there needs to be some work in the standardization bodies. Again, I don't think it's possible to define a VPN and create a standard around it, but definitely the technologies underlying the building of the VPN itself need to be better specified and, of course, interoperable. So any industry effort in that direction will be welcome, I think.
Borakil from Plurus. I have a question. Do you think that the MPLS/Layer 3 IP-based VPNs are mutually exclusive of IPsec? Because that's kind of what I got from all of your presentations, and I'm like, if my data is going over the public network, I'm going to encrypt the heck out of it anyway, because I don't trust you to keep my data from anybody else's data out on the network. So if that is the case...
Yeah, they're certainly not mutually exclusive.
Right. If that is the case, then how much of the technology that is based on actually looking inside the package to decide where they're going, and not only the IP header itself, is going to be applicable? And the second thing that I want to ask is, it looks like there's 2 different things that are going on, and maybe we should separate them. The first one is, people want to collapse multiple network plugs into one. So like the T1 PBX plug, the T3 data plug, and some other stuff into one. And it looks like the second one is to give access to the users that are coming from DSL or cable modems to the corporate networks as if you're actually there. So is this a valid observation, do you think, or there's something else out there that I'm completely at least missing?
I think it's a completely valid point. From my perspective, the answer is D, all the above. The nice thing about this is that there are all these different things available, and the downside to it is that the people have to make hard choices of what it is what they're going to deploy. But my opinion is it should be the people who are implementing the networks that make that choice. Their decisions should not be limited. The more, the better. If you want to run IPsec with MPLS, more power to you. As long as you can do it and it functions, who's to say whether that's right or wrong?
Key management?
That's not whether you're right or wrong, that's whether or not it exists or functions.
I think that the observation is that there are overlaps and there are complementing functions there. And there is no contradiction between running IPsec and MPLS. They have different strengths and they overlap in some places. MPLS is a much better traffic engineering tool, and IPsec definitely has better security. Using the 2 together gives you the best of both worlds. There are some things that you could do without MPLS, where you don't have to have MPLS. There are some things that you can do without IPsec. If you have a trusted network and what you need is good traffic engineering for separated address spaces, there's MPLS. If you have a fast network or traffic engineering is not an issue, but security between different traffic flows is, then IPsec addresses that, and the 2 together address the whole problem. So I think basically they're, like you said, tools in the toolkit. You can put them together and and there are different types of technologies for implementing VPNs.
Well, you're on.
Lane Patterson from Equinix. My question is specifically on the multiple forwarding table using BGP extensions design approach. Do you have any comments from the vendor community on implications for routing design and sort of the divergence of PE type features from core features? And as an add-on, are there concerns around that for sort of the stability of your core IBGP if you keep adding on stuff through it?
Well, I really haven't given that one much thought, to tell you the truth, but my initial gut reaction is, and I might be wrong, I am frequently, but it seems to me that one of the original motivations of both, say, MPLS and having virtual routers in a box was basically trying to solve a similar problem. What we have with IP is a legacy situation where packets were forwarded based on destination, and that wasn't good enough, especially for people right now that are doing stuff like in the academic networks, where they're having to still deal with acceptable use policies, like in the old NSFnet, where you can't send commercial traffic across, say, like Internet 2 backbones, and they have what they call a fish problem. The traffic coming from multiple sources converging into a single place, and that must be forwarded based on certain arbitrary criteria along different forwarding paths. And the way IP forwarding is done traditionally is based on destination, not based on arbitrary criteria. And there were several, ideas floated around on how to help solve that problem. One of them was to have like different routing tables and try to figure out some way to assign each type of traffic a particular community of interest, and then match it up with a particular routing table to give it a different forwarding path. MPLS solves that problem with traffic engineering now. So I'm not sure if that actually addresses what you meant by the question, but that was at least one of the original motivations for the multiple routing table thing. Right, Pedro?
I think the question was more about BGP interactions, and I mean, one of the design goals is that the VPN information should not affect your normal unicast BGP information. So they're completely separate tables. They never touch. Yes, of course, a router has only so much memory and so much CPU, but there should not be influences between carrying VPN traffic and carrying your normal BGP, your external prefixes. Does that address your question?
Partly, yeah. Can you comment on memory and CPU requirements?
Can I comment on memory and CPU requirements? The less you do, the less CPU it consumes. And memory.
Did you guys want to comment on that one too, or?
Yeah, actually, again, it's a question of what problem you're trying to solve, I guess, right? I mean, so BGP, MPLS, VPNs are great as long as your VPN reachability is limited to that MPLS cloud. But if you're looking for multi-provider or inter-provider type arrangements, then the VPN, you have to not only peer at the BGP level, but also start peering at the VPN level and start exchanging VPN information and so forth. That's an additional layer of complexity that you would have to kind of work towards, assuming multi-provider or inter-provider VPNs are an issue.
Another thing is too, I mean, I can't see any reason why I'm trying to figure out a pleasant way to say this. I mean, basically, providers are very protective of their networks. They don't like external people injecting instability into their network. So there's lots of tools that have been developed over the course of years to protect your network, like, drop packets really fast, do selective packet drop on people who flap, more than X times per X number of seconds, and all kinds of little tools like that. Lots of ways to set up route maps that you can identify, misbehaving networks based on prefix length, and all kinds of little tools right here. I can't see any reason why it would be any different when you're doing inter-provider VPNs, or that way you still use some common sense and protect yourself, because the next guy next door probably won't do it for you.
I think this question, I have a quick comment on this one. This quick question kind of digs to the heart of that trade-off that I was talking about too. Is I'm not so, and as Paul kind of mentioned, I think with BGP there's certainly a lot of tools we have where the that provider to subscriber or user boundary can be pretty well defined and controlled. We have a lot of tools to do that we've used over time and developed over time primarily at the provider edge boundary between providers, but they're also used to manage the routing that can be received from a subscriber network into the service provider network. It's where the concern lies, and I think again this is the trade-off: is if you have a simple enough network, you can use some other kind of routing protocol there, just i.e. ideally a static route between that CPE.
Static routes don't flap.
The device on the customer premise, back and forth between that and the network, and that works again in a simple network. But as we move toward a more complex, outsourcing or a virtual private network for a larger, more complex network, then we may need to move up to doing something like BGP. However, one of the concerns has been, or one of the, if the idea is to reduce complexity on the customer premise and collapse it into the network, running BGP out to the customer's device, it doesn't really seem like a way to reduce complexity to me. So again, I think those are the trade-offs that are really being faced in trying to make all these work. And I think over time, perhaps we'll evolve the tools so we understand how to do this better. But I think it's still a little early today.
If I just to add one thing, just to not scare everybody away from using VPNs, in a provider environment at least, I think that all the different mechanisms agree on a kind of an opaque core that provides a virtual network for customers. The BGP implementation for carrying MPLS information is inside that opaque core. There are other mechanisms to achieve the same thing, but from a customer point of view, from what's visible to your customers, there is no difference, there is no issue. The customer sees a static route, OSPF, RIP, whatever they want, or BGP form across that link, but that's not the same BGP that's carrying the MPLS information. So it is a different context, a different virtual routing table, if you'd like, that's talking to customers, and a different one that's handling the actual core and the overlaid things, and all the different VPN implementations that are talked about for this agree on that, I think.
Right, sure, but I think the question was along the line of, you still have those multiple processes running in one device and competing for resources in that device. So if somebody injects a full internet routing table into their local IGP, and boom, some ugly things can happen.
Don't try this out.
Unless there are other questions or comments from the audience. Oh, sorry. Yep. Okay. Sorry.
I guess my question is every vendor comes in and tells me they're IPsec compliant, and none of them talk to each other. And so I guess we're a little different because we're content provider and independent of any backbone. So we provide our own VPN services through hardware and software, and right now we're doing about 50 to 70,000 concurrent software and hardware sessions. And I guess we're coming up with the issue of when are we going to be able to use more than one provider's box, and when are they going to be able to talk to each other?
Well, I mean, that's a good question, and I'll tell you, I mean, the best tool that I know to evaluate that is to track what's going on with, like, the UNH interoperability test labs and bake-offs and stuff. Is that who's doing the IPsec stuff? Or is it just happening, there's just bake-offs wherever they're having? I think there's one prior to the next IETF. But I tell you the truth, Steve, you probably know this.
Well, I don't recall exactly where the bake-offs are taking place, but yeah, that tracking them is one of the things. The problem has been a couple of missing pieces in the specs, some of which we knew about, some of which we didn't realize were important. The one we knew about that's about solved is the certificate format. This has been the big barrier to base level interoperability. That, there was no internet standard format for an X509 certificate, so your interoperability tended to depend on whose CA your IPsec vendor was using, Entrust or Netscape or what have you. And now that PKIX is coalescing to a reasonably coherent mass, with luck, that will resolve itself in the moderately near future. The other problem at work is just starting on this, though there's some draft solutions out there, has been basically the remote configuration of a client, basically DHCP over IPsec, if you will. A few other things, but that's one of the big ones. How do you assign inside IP addresses once you've set up the tunnel? Again, vendors have their own proprietary solutions. There is a working group that's being formed to try to deal with that issue. You also have to couple in things like the desire to use legacy authentication systems, the secure ID cards, and secure keys and so on. This is also going to be dealt with by that working group. So there are a few missing pieces. Finally, and here's a place to beat on your vendors, there's the question of the administrative interfaces provided. If you've got a CA issuing certificates to your client, it comes with your IPsec box, great, and how do I take that PKIX IETF standard certificate out of one client and put it into another one's format? And here you need exchange format, and that's a little harder for the IETF to do. It's an administrative issue, a local implementation issue, and you have to beat up on your vendors and say, we demand the ability to run multiple clients with your server, for example. And these are the missing pieces that I see. People here know of others. I'd like to hear about so I can bring it back to the IETF.
Let me throw a tomato in there.
This will be the last follow-up here.
It certainly wouldn't do me. I stopped following IPsec stuff a while back.
We're actually not going to use long-term anybody's CA because we're going to do our own because we can't afford it when you got 50 to 70,000 clients. So when it has to be independent of any Entrust or VeriSign or whoever.
Comes back to a way to import and export certificates then.
Well, Susan says that there is time for another question if there is one, so. But,
John?
It has, of course, multicast, and we do multicast on it.
Yeah. John, if you don't know that, I can't answer it.
I think that's the same as for any other IP network, especially the big public ones. How do you do that?
How do you multicast to begin with? I'm just kidding, of course. That really, I mean, you're taking a complex technology, mixing it with another complex technology. I mean, what you end up with was another situation like they were talking about IPsec with lots of different little nuances. Quite frankly, I couldn't even begin to try to answer that question. I think right now we're just still trying to deal with the issue of unicast VPNs.
Want to do multicast, you can't do VPNs.
Or
you can't do MPLS VPNs?
I'm not saying that at all.
Okay.
I wouldn't even begin to.
I think multi-VPN multicast would be another, like a multi-multicast. I think that within one VPN, multicast is multicast. It's an IP network with its own space. And if that VPN happens to connect to the internet in a public way, then multicast off the public internet will work into it. There's nothing new and nothing old. It's basically the same. I don't think that you'll have a way of being able to multicast from a single point to 1,000 VPNs at that same point unless they agree to peer there.
Yeah, in some cases I think that whether or not multicast determines its own routing paths will have an influence on whether or not, whether multicast uses unicast forwarding information or not will have a great bearing on what type of VPN you can implement and have them interoperate together. You follow me on that? Because, say for MPLS is using a unicast routing system to determine forwarding paths. How would a multicast system which determines forwarding paths not based on unicast traffic interoperate with that. That makes sense, or am I just, is it time for the bar already? I don't know.
Yeah. So, yeah, a lot of interesting questions, I guess. So, I think with that, we'll wrap up, and I'll turn it back over to Susan. I'd like to thank the panelists for preparing your presentations and coming up here. And thanks to the folks out in the audience who have also asked some questions and brought some of these issues to light. So, I guess to wrap up, I'd just say watch this space. Lots of stuff going on.
Thanks very much. Thanks all of you very